The aim of this video is to go over some examples on mass and weight. If you have watched my video on mass and weight, then you can do these examples. The first one, a hammer has a mass of 1 kg. What is the weight on Earth, on Moon, in outer space? So the first one, on Earth, we said that W is equal to mg, where W is the weight, m is the mass, and g is the gravitational field strength. The gravitational field strength on Earth is 10 newtons per kg, which means that every kg on Earth is acted upon by 10 newtons due to the Earth. So the weight becomes mass times the gravitational field strength, which is 1 times 10, which is 10 newtons. On the Moon, it will be 1.6 newtons per kg for the gravitational field strength. So 1 times 1.6 gives you 1.6 newtons. In outer space, it's 0 because there's no gravitational pull in space. Now, the weight of an object on Earth is 55 newtons. The gravitational field strength on Earth is 10 newtons per kg. What is the mass of the object? Now, our formula is W is equal to mg, which means that we can make m the subject of the formula and becomes W over g. Please do write this down so that you don't get confused. You could form a formula triangle to help you understand. So W over g will be 55 over 10, giving you 5.5 kgs. Number 3, a man has a mass of 70 kgs. What is his weight on Jupiter, where the field strength is 26 newtons per kg? For this one, W is equal to mg, so you simply multiply 70 by the gravitational field strength, which is 26, giving you 1,820 newtons. Moving on. Number 4, a spacecraft travels from Earth to Mars, where the gravitational field strength near the surface is 3.7 newtons per kg. The spacecraft is carrying a probe which has a mass of 100 kgs when measured on Earth. Assuming that g is 10 newtons per kg on Earth, what is the probe's weight on Earth? Now, g on Earth is 10 newtons per kg, and the mass is 100 kg, so it will be 1,000 newtons for the weight. B, what is the probe's mass in space? So mass is the quantity of matter in an object. It does not change wherever you go. So for answers for both B and C would be 100 kgs because it does not change. Part D, what is the probe's weight on Mars? W is equal to mg, 100 times 3.7, which gives you 370 newtons on Mars. And then E, when the probe is falling near the surface of Mars, what is its acceleration? Gravitational field strength is equal to acceleration due to gravity. So 3.7 newtons per kg is equal to 3.7 meters per second squared. Number 5, what is the acceleration of the rocket below? Now, you first of all find the resultant force, 3,000 minus the weight, which is 200 times 10. So 3,000 minus 2,000, giving you 1,000 newtons. Acceleration is equal to force over mass, which would be the resultant force divided by the mass, 1,000 over 200. That gives you 5 meters per second squared. So for those of you who are still doing their Form 3 level, you do not need to stress yourself with this one. The next question is number 6. The mass of a full bottle of cooking oil is 1.3 kg. When exactly half of the oil has been used, the mass of the bottle plus the remaining oil is 0.9 kg. What is the mass of the empty bottle? Now, in this one, you can form a system of simultaneous equations whereby you say the mass of the empty bottle plus the cooking oil being equal to 1.3 kgs as shown, the first one. And then the second one will be the mass of the empty bottle plus half the mass of the cooking oil, giving you 0.90. So you could let the mass of the empty bottle be B and the mass of the cooking oil be C. So B plus C will be 1.30 kgs for the first one. And then B plus half C is equal to 0.90. And then you solve that system of simultaneous equations. You will find that C gives you 0.8 kgs, which is the mass of the cooking oil. And then you take it onto the first equation, B plus C is equal to 1.30. So it's saying B plus 0.8 equals 1.30, and then make B the subject. That gives you 0.5 kg. So the mass of the cooking empty bottle will be 0.5 kgs, which is B. Number 8, what is the mass? So the meaning of the weight of an object. The weight of the object is the force of gravity acting on it. So I think the most noble one would be B there. Number 9, what is the gravitational force that the Earth exerts on an object? Gravitational force that the Earth exerts on an object is the weight of the object. So the answer will be D there. Which relationship defines gravitational field strength? Gravitational field strength is equal to, remember W is equal to mg, so gravitational field strength will be weight over the mass. So our answer will be D. Number 11, on the Earth, the gravitational field strength is 10 newtons per kg. On the Moon, the gravitational field strength is 1.6 newtons per kg. If an object has a weight of 50 newtons on Earth, what is its weight on the Moon? So first of all, we find the mass by saying 50 over 10, right? So that would be 5 kg. So that is the mass of the object. And since the mass of the object does not change, on the Moon, it will still be 5 kgs. Then the question is requesting for the weight on the Moon. So it will simply be 5 times 1.6, which gives you 8 newtons. So the answer will be C in this case. Number 12. At a point on the surface of the Earth, the gravitational field strength is 9.8 newtons per kg. Which pair of values for mass and weight are correct for an object placed at this point? So the mass would be, so this is on Earth, so we know that G is 10. So if you say, for let's say if you take A, 9.8 times 10 should give you 98. B, 10 times 10 should give you 100. Then 10 times 10 should give you 100 again for C. And then 98 times 10 should give you 100 sorry, 98 times 10 should give you 980 for D there. So the most noble answer there would be, let's see, which pair of values of mass and weight are correct for an object placed at this point? So, okay, we are using 9.8. So if we are saying if the mass is 9.8, so 9.8 times 9.8, that's for A, it's giving you 96.04, which is wrong. For the second one, we have got 10, that's B, 10 times 9.8, giving you 98. And then the third one, so which means B is wrong. And then C, 10 times 9.8, giving you 98. So the answer is C for this one. Number 13. An object that has a mass of 15 kg on the Earth is taken to the Moon. The gravitational field strength on the Earth is 10 newtons per kg and on the Moon is 1.6 newtons per kg. What are the mass and the weight of the object on the Moon? So this one is similar to the one that we did, whereby we first of all calculate the mass. Okay, the mass is 15, we are given already. So if you say 15 times times the gravitational field strength on the Moon, so it will be 15 times 1.6. 15 times 1.6. This should give you 24 newtons on the moon. So the mass does not change, the mass on the moon and the mass on the earth. So our answer should be A for this one. So I end up again with the comparison between mass and weight. Mass is the amount of substance in the body, and weight is the force of gravity acting on the body. Mass is constant at any location, but weight depends on acceleration due to gravity at the location. Mass is a scalar quantity, weight is a vector quantity. Mass is measured in kilograms, weight is measured in newtons. Mass is measured using a beam balance or electronic balance or a pan balance. Weight is measured using a spring balance. Mass can never be zero, but weight can be zero. That marks the end of our lesson for today. Please do the practice questions on the MS Word document, and we will notify you when it will be due. And don't forget to subscribe to the Physics Tips for Cambridge students. Like, share, and comment on every post that I do